Hi, I'm Aurora with Supercharged Math. Now, I teach kids math the fun and easy way by using common sense and real-world examples. Now, in this video, I'm going to give a quick review on how to add fractions with different denominators. If you want a much more in-depth explanation, I'm going to be giving a free class on fractions where I'll be teaching this in much more detail to make sure your kids really understand and get this critical area of math. So you can register for free at getmath.net. So that's getmath.net. To divide fractions with different denominators, I'm going to take you down to my desk. Let's go. Okay. So if I said 1/3 plus 2/3, do the bottoms match? Yes, they do. So what that means is I am simply going to bring this over. We don't add the bottoms because that wouldn't make any sense. Here, watch. So for this one, 1/3, the 3, remember, talks about how many divisions you have. The 1 is how many actually you're talking about. So this is a pizza sliced into 3 pieces, but you only took 1. Your friend took 2. Okay, so what does that mean? How many pieces altogether? There's 1, 2, 3, or 1 plus 2. So you just add the top. 1 plus 2 is 3. We just keep in mind you don't add the bottom because we don't add the number of divisions. So 3 out of 3 means we're talking about an entire pizza here. Okay, so you could also say this is equal to 1. All right, so this was a quick review. What if they don't match? I have 2/3 minus 1/4. We're going to find something called least common denominator, LCD, least common denominator. And what that means is do you see that 3? Okay. Tell me, can you help me count by 3s? Here, I'll write it in another color. 3, then what? 6, 9, 12, 15, right? And it keeps going on, okay? Can you help me count by 4s? Help me count by 4s. 4, and then 4 plus 4 is 8, okay? 8 plus 4 is 12, then 16, and it goes on. Do you see any that match? Yeah, which ones match? Okay, the 12. All right, so what does that mean? That means that the 12 is the smallest number. There are more out here, actually 3. Eventually you get to a 24, and 4 also has a 24. But we're looking for the least one. L is for least, L-E-A-S-T, least common denominator. So we're looking for the one that's common to both that is the smallest. So the first one that pops up. So 3 goes into 12, 4 goes into 12. That's what we want. Okay, so this may be the confusing part, or it may actually be the easiest part for you. Watch this. If I know that 12 is the least common denominator, it's the thing that both these numbers go into, what do I have to multiply 3 by to get to 12? So here, I'll write it here. 2/3, okay? 3 times something gives me 12. What is it? Yeah, it's times 4, isn't it? So 4. So I can't just multiply the bottom by 4. That'll change the problem. I can multiply top and bottom, right? Because 4 over 4, that's the same as saying 1. So I'm basically multiplying by a clever form of 1, 4 over 4. 1 times 2/3, nobody cares if we multiply 1 times anything all day long. We can do that. Nobody's going to raise a fuss. So let's do it. 4 times 3 is 12. What is 4 times 2? 4 times 2 is 8. So we just scaled up the fraction of 2/3 to be 8/12. So you can see if I divide top and bottom by 4, I'm going to get 2/3. So 2/3 is the same as saying 8/12. So out of every 3 cookies, you eat 2. If there's 12 cookies, that means you ate 8. All right, let's do the same thing for the quarter. Okay, so we'll move this up. So 1/4, what do I have to multiply by to get the bottom equal to 12? Is it 4? No, that'd be too big, right? What do I need to multiply by? That's right, 3. Now, can I just do the bottom, or do I have to do the top too? Yeah, I have to do the top. Okay, in order to multiply this fraction by 1 and not break any rules, I have to multiply top and bottom are the same. Okay, so you tell me, what is 3 times 1? You're like, oh, that is too easy. And 3 times 4 is 12. All right, so the original problem was 2/3 minus 1/4. Okay, so this is going to be 8 over 12 minus 3 over 12. Do you see how the bottoms match now? Oops. Let's get that up there. Okay, do you see how the bottoms match? All right, so these must match, and if they don't, you have to scale one or both of them up. We scaled both. And then you just do whatever you need to do at the top. This is an 8 minus a 3. 8 minus 3 is 5, and you carry the divisions. Remember, you don't divide or do anything weird with the bottom, okay? You just keep those in there. All right, so we did it. That's the process of doing this. And if you're like, wow, that took a lot of energy. Well, the first time you do anything, it takes a little longer, right? Okay, so let's practice so we get really good at this. Okay, so the next problem I have looks like this. I have 4 over 7 minus 1/5. What is the smallest number that 7 and 5 both go into with no remainders? Okay, in this case, it's 7 and times 5, right? Because this is 5, 10, 15, 20, 25, 30, 35, okay? So, and 7 doesn't end in a 5 until we get to 35, right? So the smallest denominator here is 35. So what do I have to multiply the bottom by? Okay, so let's work on this one first, okay? So 7 times something gave me 35. Do you remember what it was? 7 times 5. So I'm going to multiply this one by 5 over 5. 5 times 7 is 35. 5 times 4 is what goes on top, the 20. Okay, what do I have to multiply the 5 by, just look over here, to get 35? What do I have to, is it multiplied by 5 over 5? No, it's 7 over 7, isn't it? Because I need 5 times 7 is 35. 1 times 7, this dot is a multiply. 1 times 7 is 7. Do you see how I scaled this one up first and I didn't do anything with the other side yet? And I scaled that one up first. So you're going to take each one in turn, and now you get to do the fun part. Okay, so write down 35 on the bottom, and 20 minus 17, that is 13. And I can't reduce it anymore. 13 is prime, and 35, it doesn't have 13 as a factor. So there's your final answer. Let me show you another way to do this. So if I want to make the denominators the same, 3 times 4 is 12. 3 times 3, this is going to become a 9 over 12. 4 times 2, that's going to become an 8 over 12. So the 8 over 12 is here. The 9 over 12 is here. And I simply add them together. 8 plus 9 is 17 over 12. Why does that work? Because essentially what we're doing is saying the common denominator is what happens when you multiply them both together. So really what we're doing is we're taking this 4 and multiplying it by the 2 to get 8. And that's what we have here. And we're taking the 4 and multiplying the 3 to get 12. So we're just multiplying it this way. It just makes it a little easier to think about it this way. So this 3 is going to be multiplied by 3 to get the 9. This 3 is multiplied by the 4 to get the 12. So we have 12 on both sides, which tells us we can add just the numerators together to get the final result. 1/5 minus 1/12. Let's do a subtraction one. What is 5 times 12? 5 times 12. Now this is, don't worry about least common denominator. 5 times 12. What do you think it is? Yeah, did you get 60? Did you get 60? All right, so what you do is you write the bottom down here and then whatever the sign is, okay? And then what you do is you just go, okay, 5 times 1 is a 5, okay? And it's going to be over 60. And a 12 times 1 is a 12 over, and they're going to be over the same thing. So this is, that's the wrong number, wrong color. 12 over 60 minus 5 over 60. So it's the same thing we were just doing, but we're just saying, well, 12, I'm going to multiply it top and bottom. So I have 12 over 60. And the 5, I'm going to multiply it top and bottom. So 1 times 5 is 5. And 5 times 12 is 60. And then 12 minus 5 is 7 over 60. By the way, if you'd like to join me for a complete lesson on basic fractions where I go into more detail on adding fractions with different denominators as well as several other critical areas of working with fractions, I'd like to invite you to join me for that free class. You can register at no charge at getmath.net or by clicking this video. I will wait right here while you register. Okay, so that was a quick review. If you want the full explanation of every step that we've just done together with lots of examples, I'm going to be giving a free class on this. You can register for it at getmath.net or on this page. Thanks for joining me.